In this video, we're going to take a look at a couple of examples that utilize the rules of integration that we talked about in the previous video. And of course, one of the most common rules that gets used is the power rule. So when I take a look at a problem like this, where I'm asked to integrate a function with respect to x, I want to make sure that each one of my terms is set up to be integrated nicely. So in other words, I want to make sure that each one of my terms is written as a coefficient, variable, and a power. So that means that if I've got x's in denominators, I want to move them up. If I've got x's underneath roots, I want to write that as a fractional power. The one exception is that if I have a fraction where I've got x in the denominator and x is to the first power. Remember that anytime I have x to the first in the denominator of a fraction, that has its own rule. That's the logarithmic rule for integration. So that's the only kind of term that I wouldn't want to rewrite. Now in this first example, everything looks perfect. Everything has a coefficient, variable, and power. So this, I'm just going to go through and use the power rule on each one of these terms. So I want to integrate each one of these terms in that function one by one. So we'll start with the integral of x cubed. So remember, the power rule says you take the coefficient that's there, you divide by the exponent plus 1. So I'll divide by 4, and then the new exponent on my variable is also the exponent plus 1. So 1/4 x to the 4th. Now I'm going to move to the second term, 6x squared. I'm going to do the same thing. So I'm going to have my plus, my coefficient that was there, divided by the exponent plus 1. So 2 plus 1 is 3, and the exponent is going to be the old exponent plus 1, so x cubed. Remember that the number you divide by out front should always be the same as the new power on your variable. So moving to this third term, I've got minus the old coefficient divided by the exponent plus 1. So this old exponent here was 1. So when I add 1 to it, I'm going to divide by 2, and 2 will be my new power. Plus, now my last term is a constant, so there I'm going to use the constant rule, which says that I take that constant and I multiply by the variable. And then you don't want to forget that in your answer, you're always going to have your plus c, your constant of integration. So now what I want to do is just kind of clean this answer up. So any coefficients that can be simplified, I want to simplify them. If I had any negative exponents, I'd want to make them positive. So just kind of clean up the look of the result. So I'm going to have this first term, which is fine, 1/4 x to the 4th. You can put x to the 4th over 4 if you wanted to. I prefer the coefficient to be out front in front of the variable. Plus here we've got a coefficient that can be simplified. 6 divided by 3 is 2, x cubed. In the next one, 6 divided by 2 is 3, x squared, and then plus 3x plus c. So there is my result in simplified form. Okay, let's take a look at another example. So in this one, I've got some, ugly looking terms. So what I'm going to first want to do is rewrite any terms that aren't already in that form of ax to the n. I want to rewrite them that way. So now if any one term needs to be rewritten, then make sure that you rewrite the entire problem before you start integrating. You don't want to integrate any term until you're ready to integrate all of the terms. So I know that I want to rewrite that one there. I want that x brought up to the numerator. My next term is fine. This term here is fine because remember, x to the first on the bottom has its own rule. And then I've got minus 3/2 square root of x. So that term I'm going to want to rewrite because I'm going to want to pull that x out of the root position. So let's go through first and rewrite this. So I'm going to have my integral symbol. And if I start with this first term, 4 over x cubed, I want to write that as 4x to the negative third. Pull that x up to the top, makes its exponent negative. The next term was fine the way it was, so I'll just rewrite it. Even though it was ready to integrate, I'm not ready to integrate the entire thing. So I'm going to rewrite that first before I start integrating. 8 over x remains the same. And in the last one, I'm going to take that x out of the square root symbol and give it the power 1/2. So I've just taken that function and rewritten it in a form that I prefer. So I want to integrate this. So let's start the integration process. So if I start with 4x to the negative third, my power rule says I take the coefficient that's there and I divide by the exponent plus 1. So -3 plus 1 would be -2. And then that -2 will also be my new power. My new exponent is the old exponent plus 1. For the next term, I've got my old coefficient of 2 divided by the exponent plus 1, so divide by 6, and that's going to be x to the 6th. I'm on my third term now, this 8 over x, remember that's the logarithm rule. So the first thing I write down is the numerator, and then I take the natural log of the denominator. And I want to put absolute value around that x just to ensure that that remains a positive value. My last term, my coefficient is 3/2. So I'm going to put that in my numerator. That's what we do for the power rule. The coefficient divided by the exponent plus 1. So in this case, my coefficient is a fraction. We'll clean it up later. So it's my coefficient divided by exponent plus 1. And my exponent was 1/2. So if I add 1 to that, I get 3/2. So I'm taking 3/2 and dividing by 3/2. And my new power will be 1/2 plus 1, which is 3/2 as well. And then my constant of integration. So now we'll just go through and clean this up. Simplify our coefficients, make any exponents that are negative, positive, and we can go back to root notation if we want. So 4 divided by -2 is -2 for my coefficient, and I want to drop this x back down to the denominator since it has a negative exponent. So I'm going to write that as -2 over x squared. Minus, my coefficient here can be reduced to 1/3, x to the 6th. My ln term is fine the way it is, so I'll just rewrite it. Minus 3/2 divided by 3/2, that's nice because anything divided by itself is 1, so my coefficient is 1, and my exponent is 3/2. And then there's my constant of integration. So I'm good with this answer. If you want to have root notation here, you can do that as writing this term as minus. Now my denominator is 2, so that implies square root. My numerator is the power on the x. So you could write that term as minus the square root of x cubed if you wanted to.